Ok, bah, je vais commencer, je pense. Okay, so hello everyone. So my name is Yannick Badoual. I'm a developer at Deezer. And today I'm going to talk to you about Dagger-android. More precisely, I'm not going to show any generated code by Dagger. I'm just going to present to you what's really going on when you're using Dagger-android that was released, I think, last summer, something like this. Okay. So first, quickly about me. So you can join me on those different links. I joined Deezer about 6 months ago in September. I have a few open source libraries that you can find on GitHub, and also a few applications on the Play Store if you want to check. So quickly, the plan. First, I'm going to talk a bit about the context, so why I choose to do this talk today. Then I'm going to explain quickly what is dependency injection, and present to you two annotations that were existing before the release of Dagger-android. And then we are going to talk about the real topic here, Dagger version 2.10 and 2.11, that brings a lot of new features for Android developers. So first, some context. So at Deezer, we use Dagger for dependency injection, and I guess everyone here knows what Deezer is. And we have a lot of activities and a lot of fragments. And so we have a lot of dependencies, and Dagger helps with that to keep a maintainable code. And with the previous version of Dagger, we add a lot of boilerplate code. And we decided to migrate to the new version to remove some of that boilerplate code. And the reason I chose to do this talk is because when I started to get interested in Dagger, so when I joined Deezer, I knew almost nothing about Dagger. I knew it was this mystic library that was helping with dependency injection, and everyone was talking about it, but that's it. And I got interested, and I wanted to know what was really going on with this new version, where you don't see everything. A lot of things are hidden with generated code. And I found no talk or article on this topic. So I chose to do this one today. And also, after talking with a lot of developers that were using Dagger, and I realized that a lot of people don't really understand what's going on when you use Dagger-android with this ContributesAndroidInjector annotation. So I thought it was a good idea for everyone to really understand what was going on. About dependency injection first, I thought it was a framework like Spring, Dagger, AngularJS or whatever. But no, it's a simple concept, and frameworks are just here to simplify it. If you check a definition, you can read something like dependencies are supplied to an object instead of creating or getting it manually. So quickly, what does it mean? Here we have a simple class. So it's a simple repository that you could find in Deezer code source. So this one we create our DAO manually. And this version is using dependency injection. So instead of creating it manually, we get it from the constructor as a parameter. And the interest of this is that it's easier to mock. You don't need to have a setter or something like this to be able to inject your mock. And you can effectively use finals. You don't need to make it non-final just so that you can inject your mock. So if it's easier to mock, it's easier to test. It's also easier to maintain. And you have multiple ways of doing it. Here we're doing it via the constructor. But as I said, you could also have a setter or a factory provider, whatever you want. And frameworks like Dagger are here to do this for you. And with this, you won't have to call the constructor manually. So here we have a simple case, but your constructor could have like 10 or 15 dependencies. And creating it manually every time can be a pain. So here it will be done automatically by Dagger. About Dagger now, you have a lot of presentation and articles on Medium and YouTube that you can check. I will not explain what Dagger is on the simplest level. We are going to talk directly about what's going on. But just remember that Dagger works with a graph of dependencies, and this graph can have multiple components that can be connected or not. And each component is composed by one or several modules that you can reuse across different components. So here you have a links of several talks or articles that you can read that are very interesting. So first reminder, I will talk about the binds annotation. If you read the Java doc, you will see that methods are drop-in replacement for provide methods that simply return an injected parameter. So, okay, what does it mean exactly? It's very simple. I think everyone already wrote something like this. Everyone using Dagger already wrote a method like this, where you would take a parameter of some type, and you will actually upcast it to hide it as an interface or as a superclass. Here we're taking the application instance and we are upcasting it to a context. And this can be done automatically because you would have a lot of conflict. So you need to do it manually. And just a note about this particular example, it's a bad practice because here you are providing a context, and it means that anywhere you could have a dependencies that requires a context, and you would actually inject the application context, but you wouldn't know that at the place where you need it. So it could be an activity or whatever. So when injecting context, I recommend that you use a qualifier, like you create your own annotation or named qualifier. And here, to avoid having to declare a body for the function, here it was in Kotlin, so it's pretty simple, but in Java, you would have to actually open a body, then add a return statement. So here, the binds annotations lets you skip that. You will just declare an abstract function with a signature, and the rest will be generated. And the only constraint of this is that your module would, when you have a binds annotation, so your module has to be abstract because of this abstract function. And the issue with this is that if you have other provides method with a provides annotation like we have above, you would need to make them static to be in your abstract module. I'm not sure why they chose to do it like this, but you need to do it. So it can be an issue if your modules, if you need to have parameters that are injected in your module constructor. So here we have the two versions with the provides and one with the binds, and you can see the difference. The annotation, one is abstract and don't need to declare the return statement. Then BindsInstance annotation. So it marks a method on a component builder that allows an instance to be bound to some type within the component. So again, what does it mean exactly? So here you have a component that is pretty standard before Dagger-android, before the release. So you will need to declare your component with your scope. So here an activity scope. You would also need to add an inject method that would be generated for your activity. And then you would have your subcomponent builder. And what's very interesting here is the login page activity method. So here it's annotated with the BindsInstance annotation. And you can see that it takes as a parameter our login activity, and it returns the instance of the builder. So using this will effectively allow you to remove a constructor parameter on your module, so you won't need to construct your module manually. Instead, when you build your components, you will just pass your activity as an argument, and it will be accessible in your dependency, in your graph, so in your module in this component. So when using it, you can just have a method like this in your module. So here we're reusing the binds annotation that we just saw. We have a method that takes a login activity as a parameter, and which return a view of the login page contracts. So supposing we are in a MVP architecture. So we just bind the activity to our view. And we won't need to provide the activity manually because it will be done automatically via the annotation that we just used. And when creating your components, you will create it like this. And on your builder, you will call this method that we just declared. And this here is the activity instance that you're injecting to your component. It's important to note that when using this annotation, what it actually does behind the hood is that the instance would be saved in the builder, and when creating your component, the builder will be passed to your component that will access the instance from your builder, but your builder will keep the instance inside even after the component is created. So this is very important for later. I will explain why later. So now we're going to talk about Dagger 2.10. So a very important version for Android developers, as it makes life easier for us, and we have to write less code now. So the issue with Dagger is that, more precisely with Android, is that we can't use constructor injection for framework type because you cannot pass arguments to fragment constructor. At least you shouldn't. The same for activities or any framework type. And also, before this version, you had to build most of the time the components inside your activities and your fragments manually. And this is contrary to the principle of dependency injection because a class should not know anything about how it's being injected. But in our activities of fragments, we were creating the component that would actually inject us. So there is something wrong here. So here I'm going to show quickly the tree of our graph of dependencies that we will use through this talk. Sorry. So first we have our app components. That's the root component of the project. So pretty common. We would have the AndroidInjection.module. So this module is not something that you have to write yourself. It's something included in the Dagger library. And you also have the Android support injection module that you will probably use if you're using fragments, as it's needed for super fragments. Then you have your app module. So this is the usual module that you were using before with all your dependencies that can be split into multiple modules if you want. Then the new point here is the activity component binding module that you can call as you want. I choose to call it like this. And this module will be used to declare our subcomponents. So for activities, fragments, and so on. So this module will first declare one subcomponent, so for our main activity, that will itself have one module, so the main activity module, and the same thing for detail activity. So we keep it simple here, one main activity, one detail activity. So each component has one module. So this is our graph of dependency, so we keep it fairly simple for this topic. Next, you don't need to understand all of this right now. It's just to show you, like, it's the actual flow of what we're going to see today. So we will start from the main activity and end in the component of this activity to inject it. So we are going to go step by step. And first, I will start by explaining one interface that is used everywhere, basically. So it's the base interface for all your components or subcomponents. So it's an Android, it's the Android injector interface. You can see that it has one type parameter. This interface only has one method, the inject method, that takes one parameter of our type parameter. So pretty simple. And the content of this method will actually be generated by Dagger at compile time. So it's basically as usual when you add your component or subcomponent and you were adding an inject method to inject your activity or your fragments. It's the same thing. So here you won't have to, just by extending this interface, implementing it, sorry, this interface, you won't need to declare this method manually. So you will gain some time. Then we have a nested interface factory that also has one type parameter and will serve to create an instance of our Android injector in a one line. So you just have to pass the instance as an argument that you want to seed in your component. And then you have the standard builder class that will serve for your subcomponent builder or your component builder. So we're going to go step by step. First, you can see that this builder implements the factory interface that we just saw. So we implement the create method. And sorry, I forgot to explain. When you see the Google logo on the top right corner, it means that this code is part of the Dagger library. So it's not something that you will write yourself. So here, all of this class is part of the Dagger library. So we implement the create method. So all we do is call the seed instance method with our parameter, and then we return the result of the build method. The seed instance method is something that we just saw. It's just a BindsInstance method. So what it will do is that the instance passed as an argument will be saved in the builder, and then will be passed to the component when calling the build method. Then the build method, so pretty standard, that's something we already had. It's worth to note that this method will always return an Android injector. So you will have to cast it manually if you want to actually get your component as your component instead of an Android injector. And you cannot, this method is final, so you will not be able to redeclare it to specify the return type. So we have this big interface, and we need it because for framework type we cannot use the constructor injection. We have to declare this inject method and do it manually. Next, another interface in the Dagger library, the as activity injector. So it's pretty simple. You just have one method that will return an Android injector for an activity. And you have the same interface for different framework, for basically all the framework types that you will need to inject. So fragment, super fragment, broadcast receiver, service, and content provider. Next, we will start to see the code that we have to write ourselves. So this is the code that you will need to write. So you declare your app component. As you remember, the app component is a root component of your dependency graph. So this component will extend the Android injector, implement the Android injector that we just saw. And the type parameter will be Android sample app. So this is a class extending the application class here for this talk. We declare also a builder that is also implementing the builder interface that we just saw. And that's it. You don't need to do anything inside the body. So the method are present in the interface, so you don't need to do it manually. And the important part now are the modules that you will include in your components. So as we saw before, you have this Android injection module. and Android super injection module if you need. Then you have the activity component binding module that we will see a bit later. And finally, the app module with your standard dependencies that you already had before. So now we're gonna start to take a dive into the flow. So what's happening? How do I inject my activity? So we start with the bottom. So we have our main activity component and our detail activity component. So one component for each activity. So let's check the declaration. So as the component is fairly simple, those components only have one module and are implementing the Android injector and the builder interface. So as you can see, it's a bit boilerplate, but we will talk a bit about this later. And the same thing for the detail activity. So you just have to declare the class and the builder, and you don't need to declare any method whatsoever. It's also worth to note that you can add, still add the scope. Here I didn't put it on detail activity. It's intentional. I will explain a bit later why. So you have the two declarations of our components. So fairly simple. It's something that you probably saw, or maybe not if you started to use Dagger 2.11 directly. So we have two activities, one component for each activities, and now we want to inject the activity with the right component. So how do we do this? So let's check the declaration of our activity. So first, you can see our injected parameter, injected field. So it's worth to note that you can inject the actual component, so it can be useful sometime. And then we inject a presenter that is declared in our contract. So nothing fancy. Also, I want to precise something. I saw a talk where the speaker was recommending to use the unwritten non-configuration instance method to actually save the components to reuse it when the activity is recreated, so after a rotation or configuration change. There was actually a discussion about this on the GitHub of Dagger, and this is not something that you should do, because in your components you might have some bindings using the instance of your activity. And basically what it means is that if you save the components, the instance of your activity will also be saved because it's used. And you're basically leaking your activity, so please don't do this. And if you need to save the component across the configuration change, it probably means that you need something else than the activity scope. You need something higher. Next, the very important and magic line here, the inject method on the Android injection class. So we just call this magic static method, and everything happened here. And also please note that you should always call this method before calling super.onCreate, because the calling the onCreate method on the superclass can lead to fragments being recreated, and your fragments might use also Dagger. So you would try to inject your fragments before having injected your activities, which could lead to some bugs. So be careful with this, or just use the Dagger app compat activity. You won't need to do this manually. So we just saw that the activity will call the inject method, and now what next? So the static method, this is the Kotlin version. The library version is in Java, but this is basically the same thing converted to Kotlin. So again, this is part of the Dagger library. So step by step, first we get the application instance from the activity, and we try to cast it as an instance of the AsActivityInjector interface. And if it's not an instance of this interface, we will just throw a runtime exception. So be very careful. If you test your code, you will see it right away, because it will crash if you try to inject your activity, and if you forgot to to make your application implement this interface. Then we get the activity injector via the method that we saw in the asActivityInjector interface. And then we call this inject method that is basically equivalent to calling the inject method on your components, but not exactly. We will see why. So we just took one step further down. So now what's going on after you call this? What's going on in the application class? So this is the declaration of our application. So pretty simple. We have a class extending application implementing the asActivityInjector interface. Then you can see that we are injecting a dispatching Android injector of an activity. We're going to see later what it is. And we are implementing the activity injector method from the interface to return this injected field. We're creating our component, so in a lazy fashion, so that you don't create it when you don't need it. And you cast it as an app component. And then you inject your application so that the activity injector will be injected. And please note that this code is actually incorrect because you should probably always use the Dagger application class when you want to use Dagger-android, because calling the inject method like this could lead to some bug if you're using content provider, because sometimes the onCreate method of the content provider will be called before your inject call here. So the Dagger application class makes sure that these kind of things don't happen and that you don't get weird bugs. So be careful. And then, as you see here, our activity injector, even though we are returning an Android injector, is in fact a dispatching Android injector. So what is this class? We will now see what it does. So this is the declaration of the dispatching Android injector class. So again, Dagger class. So you don't need to create it manually. So this class is implementing the Android injector interface and also takes the type parameter as the Android injector. We use an injected constructor is used, so you won't need to provide this class manually. And the only injected field here is a map, so the signature can be a bit complicated at first. So the key on this map is a class of something extending or type parameter, and the value will be a factory of something extending or type parameter. And the important part here, the inject method that is implemented from the Android injector interface. So we have an instance as a parameter that is our activity instance that we're trying to inject. So first, what we're going to do is that we're going to access the map to get a factory from the class of our instance. And this line is very, very important because it's the reason why when you declare your subcomponent, you actually have to use the actual type of your activity and not a super type. And this is because here we are accessing the class on the instance. So if you're using a super type, you will find nothing in the map. And as you can see here, it will throw a runtime exception. So be careful. So we use the instance to get the class and then the factory. And with the factory, we call the create method from the instance. And then we just inject our instance. So that's it, it's done. But it's not so simple because here, what I just saw here, it's a mistake. It's not the real code. It's a simplified version because as you remember, when I explained what the BindsInstance annotation does, it actually saves the instance inside the builder. So here, our Android injector builder, and it will save it and never erase it. So here we are reusing the same factory again and again. What it means is that after this inject call, the instance will still be present and saved inside the factory. And this is effectively a memory leak. So this is not the real code. The real code looks like this. Instead of having a map of a class to a factory, you will have a map of a class to a provider of a factory. So it's a bit complicated, but it's done automatically with Dagger. Instead of providing your actual dependency, Dagger allows you to provide a provider of these dependencies that you can call to get a new instance every time that you want. So the rest of the code is basically the same. You use the instance to get your factory provider, and one extra step on the provider, you call the get method to get a new instance of your factory. So each call will use a new factory instance, and you won't have any memory leak. Next, I will talk quickly about multi-binding. So multi-binding can be quite a bit complicated when you're fairly new to Dagger. I will not explain in detail what's happening and how it works. You can check the documentation of Dagger. It's well explained. But quickly, here, it's the activity component binding module that we saw before. So this is not something part of the Dagger library. It's something that you have to write yourself for each of your components that you want to declare. So here we are attaching two subcomponents to our module. So one for the main activity, one for the detail activity. And you will have to add one method for each component. So you have a lot of annotations. We are going to go step by step. First, we are using the binds annotation that we already saw. So what we are doing is basically we are binding the builder of our component to a factory that we saw before of something of an activity. Then we are using the into map and activity key annotation. So this is the multi-binding, and what it does is that you can have multiple entries in your modules that will use these annotations, and it will allow you to inject a map as we saw previously. So here we are basically, the key will be the main activity class that you declare with your activity key annotation. And the value inside the map will be the return value of your method. So basically with this method, you will add an entry in your map where the key will be the main activity class and the value will be the main activity component builder that is upcasted to a factory. So you can see that the only real specific part here is for the activity key and the components. And we are doing exactly the same for the detail activity here. So no differences, the only difference will be the type of the builder that you want to bind and the key for the map. And using the multi-binding will allow you to inject a map like this that we saw before. So the key is the class and the value will be your factory. So from an actual instance, you can get the class, and from this class, you will get a factory of something that will inject your instance. So there is one issue with multi-binding is that I'm not sure why they choose to do it like this, but with multi-binding, by default, you cannot inject an empty map. If you try to inject a map with no method that will provide at least one entry, you need to use the multi-binds annotation. But we have a class in the Dagger library that does it for us. So this is why you need to add the Android injection module, because it will declare these methods, and these methods will make sure that even if you don't provide any entry for your maps, you won't have any crash and bugs at compile time. So you have one method for each type So here the activity, the fragment, and you have the same thing for the broadcast receiver, support fragment, etc. So if you take a look, that's what we just saw. We saw all the classes here. And if you take a closer look at the components, as we said before, you have a lot of boilerplates. I don't know about you, but I don't want to recode this every time. It's basically copy-paste all day. And this is where Dagger 2.11 gets interesting for us. So this doesn't change, basically the same thing. And the new point here is that we skip the declaration of the components. We will just have to declare our modules with our dependencies. And we can do this because we have the ContributesAndroidInjector annotation that will do some work for us. And if you check the Java doc of this annotation, generates an Android injector for the return type of this method. The injector is implemented with a Dagger subcomponent and will be a child of the module subcomponents. So how do we use it? Basically, we add the class where we were attaching our subcomponents. And here it gets simplified. You don't need to use the binds annotation yourself. You don't need to use the key or into map. All you will have to do is have one method with the ContributesAndroidInjector annotations, and you can add several arguments. One of them is the modules, so you can list the modules that you want to attach to your generated component. You also can drop the parameter, you don't need it, and you only need to have your return type. And the return type here is very important. As I said before, you cannot use a super type. You have to use the actual types of your component that you want to inject. So here, let's say that we have a main activity extending a base activity class. You cannot declare your method with a base activity return type. It will not work, at least not with the basic classes. Also, since we don't declare our component ourselves manually, if you want to keep using the scope, which you probably won't, you can use the scope annotation on this method, and it will be applied to your component. So here you don't see the scope on the detail activity because, as I said when I started, I didn't put any scope on this component, so it's okay. It's not mandatory. And here you can see highlighted the only differences between the two declarations. So the module list and the return type. So this is the final slide, but since I have some time, I will just, okay, I'm missing one slide, sorry. As I said, you have to use the actual type to declare the actual type for the return type of your method, because it won't work if you're not doing this. But you can basically cheat and create your own version of your dispatching Android injector. And you have multiple ways of doing it, but for instance, instead of accessing the class directly on the instance that you want to inject, so when getting the factory from the map, what you can do is, for instance, have one interface, like get class with one method, get class for injection, and you can check if your instance is an actual instance of this interface, and then you will be able to retrieve a class from this method and use this class to retrieve the factory from your map, or you can just iterate through the parent class of your instance. Like you use get class on your instance. If there is nothing in the map, okay, let's get the super class, check if there is something in the map, etc. So you have multiple ways of doing this. Feel free to do it, and that's it. I think we have time for some questions. Yes. Yeah. So any question?